Starship Flight 13 finally launches, and there's lots to talk about. Meanwhile, Blue Origin continues refurbishing its destroyed launch pad, but why is it moving around a Stage 2 strongback? Rocket Lab plans to build more launch sites, RFA ONE is vertical on the pad ahead of its maiden flight, and India's first private rocket reaches orbit on its very first attempt. As always, we've got all that and more coming up this week in Spaceflight. Okay, we'll get to Starship in a minute, but first, we've got another massive methane-powered rocket to talk about, or rather its launch pad, as Blue Origin makes steady progress with its overhaul of Launch Complex 36. Now, they didn't originally plan for that redesign, but their hand was forced in late May when their New Glenn rocket experienced an anomaly during a static fire test. The explosion that followed wiped the rocket off the face of the Earth and left the launch site in a completely unusable state. Fortunately, the keep-out zones did their job, and no one was harmed. Since then, they've been working on getting the site back in order again, and a few weeks ago, CEO Dave Limp announced a 5-step plan to return to launching. In addition to working on the repairs, they're now also in the process of designing how the new launch pad should operate, known as its Concept of Operations, or CONOPS. Future launches from LC36 will look quite different, with Blue opting not to use a transporter-erector and instead placing the rocket on the pad using cranes and connecting some of its umbilicals to the launch tower. According to Blue's plan, they should have completed the cleanup a while ago, but it seems that there was still at least one thing left to clear out: the massive launch table that supported the rocket before liftoff. This week, Dave Limp shared a video of a crane hoisting the massive structure out of the flame trench that it had collapsed into. It was then moved into the horizontal integration facility, which now has its doors removed, as they probably also took a beating from the explosion. Inside the hangar, Blue plans, quote, inspection and adjustments for the launch table. Considering that some parts of the structure look bent and warped in the video, it'll certainly need some refurbishing too. Once back on the pad, Blue plans to outfit the launch table with some new hardware to support the new CONOPS. First, it'll host the umbilicals that will connect to the aft of New Glenn's first stage. With no strongback to connect these lines to, the launch table seems like the logical place. Additionally, the table will be plumbed into the pad's water deluge system to inject water below the nozzles of the 7 BE-4 engines installed on Glenn Stage 1. This helps dampen some of the energy coming out of the massive rocket at liftoff. But the launch table wasn't the only big piece of hardware on the move this week. Our Space Coast Live cameras also spotted Blue's transporter-erector on the move. Nope, not the transporter that was destroyed in the explosion, but a shorter one that Blue uses for testing New Glenn's second stages. It was offloaded from a barge at the Kennedy Space Center this week. We assume that this is the same one that they used to have over at LC36, but what are they going to do with it? Will it even be compatible with the new CONOPS? Well, the short answer is that we don't know. But if you'll allow us to indulge in some speculation, this week we also saw a Blue Origin proposal to build 4 lightning towers in the Merritt Island launch area, not too far from Blue's Exploration Park facilities. Now, this is a very strange location for a launch site, and the proposed towers won't be near tall enough to support a full New Glenn. But, and here's where the speculation comes in, what if they're planning a test stand for Glenn Stage 2 in that location? That would allow them to keep testing the stages in the way that they've always done it, regardless of the changes to LC36, and it would also explain why they moved the transporter-erector over to the Kennedy Space Center. But Blue might not even need a Stage 2 test facility at KSC. Later in the week, the company posted an update announcing that they signed an agreement with NASA to use the B test complex at NASA's Stennis Space Center. NASA previously used the stand for testing Saturn V first stages and space shuttle components. Most recently, they tested the SLS core stage on that stand. Blue now plans to use the complex for second stage testing, which the company says is to deconflict LC36 launch operations. That doesn't mean that they won't also test second stages at the Kennedy Space Center, but it could mean that they've got different plans for whatever the Merritt Island launch area will be. I guess it's yet another thing for us to keep our eye on. Just like how you should move your eyes over to the like and subscribe buttons to make sure that you've clicked them. Either way, Blue's moving very quickly with their refurbishments, and they're still saying that they want to be back to launching before the end of the year. We'll have to see it before we believe it, but they're certainly not sitting still. And now, over to Ryan for all of the details on Starship Flight 13.
Thanks, Alicia. We finally had a launch of Starship this week, unlike last week where we saw that abort at T0. Yesterday, SpaceX explained that 4 of Super Heavy's 33 Raptor engines failed to ignite. The automated launch commit criteria will abort the launch if more than 2 Raptors are not running. Following inspections and analysis of the data, SpaceX found that 6 engines had experienced issues with their oxidizer turbopumps failing to reach flight speed. The company explained that the most likely root cause was moisture left inside the pumps from previous operations, which then froze and prevented the turbopumps from spinning properly. Engineers replaced the affected engines and reset for another launch attempt this Thursday. However, poor visibility forced SpaceX to scrap that attempt and slip to Friday. That's why this episode is releasing on Saturday rather than our usual Friday. Thanks, Starship. Engineers needed clear visual tracking of the ship during ascent because they were deliberately flying through a region of higher aerodynamic pressure in order to further stress test the heat shield tile attachment system. So, with clear skies on Friday, SpaceX gave it another go and we finally saw Starship lift off. While Flight 12 was largely successful, there were still several issues that needed to be addressed and validated on Flight 13. These included improvements to the booster's return, while the ship needed to demonstrate that it could successfully relight one of its Raptor engines in space. Some of those issues remained, while others were finally resolved on this 13th flight. Last flight, SpaceX trialled a new method of performing the booster's directional flip after hot staging by changing the ship's engine startup sequence, but it did not work as intended. For Flight 13, the company introduced a revised approach that is more tolerant of slight variations in engine startup timing, and this time the maneuver was completed successfully. Super Heavy successfully flipped back for its boostback burn and reignited the 28 engines it had shut down before hot staging, allowing it to perform a full 33 engine boostback burn, something that did not work on Flight 12. During the boostback burn, the plan was for the booster to gradually shut down its engines in stages, starting with all 33 engines, then reducing to the 13 inner engines, followed by the center 3 engines, before completing the burn. Although the 33 engine phase of the boostback burn was completed as planned, SpaceX later explained that the burn ended earlier than intended. This is also apparent when comparing the flight timeline with the schedule SpaceX published before launch, and the fact that the booster's explosion appeared much further away than expected on our tracking cameras. Speaking of which, the landing burn did not go quite as well. Several engines failed to ignite at the start of the burn, while others shut down during the final descent, with the end result being Booster 20 plunging into the Gulf. That said, it impacted the water at a much lower speed than Booster 19 did on Flight 12, thanks to the few engines that continued running throughout the final descent. It did its best. While that marked the end of the road for Booster 20, Ship 40's flight was a success in every respect. There were no engine shutdowns during ascent, the ship reached its planned suborbital trajectory following SECO, and, for the first time ever, successfully deployed operational Starlink version 3 satellites in space. This was one of the main highlights of the mission. Up until now, SpaceX has only flown simulators on these starships, but Flight 13 carried 20 real Starlink V3 satellites on board. These were deployed to test their onboard systems before mass-scale deployment begins later this year on future Starship flights. All 20 Starlink satellites were deployed, and SpaceX later confirmed that they established contact with all of them through both radio signals and the Starlink laser links. Once operational, Starship should be capable of launching up to 60 satellites at a time, deploying several times more capacity than any of the Falcon 9 launches we regularly cover. Of the 20 satellites deployed, at least 6 were fitted with lights so their onboard cameras could capture images of the ship's thermal protection system before re-entry. While we were able to see the lights from the satellites and the ship rotated to point its tiles towards them, SpaceX hasn't released any imagery. Hopefully they'll share this in the future. With the satellites deployed, Ship 40 then prepared for its in-space relight demonstration. The burn was much longer than previous demonstrations, with a planned 14-second burn instead of just 3. You can see the Starlink satellites drifting out of view as the engine starts and the ship flies away from them. So, with a successful relight demonstrated, the ship then hit entry interface and prepared for splashdown. This was the 7th ship to begin re-entry in the correct orientation, and once again it managed to fly through and survive both the plasma phase and the period of maximum aerodynamic pressure. The vehicle performed its dynamic banking maneuver, simulating its approach to Starbase's Pad 2, and successfully completed its flip and landing burn. To the surprise of everyone, including SpaceX, the ship survived its tip-over after splashdown and remained floating in the water while continuing to send telemetry and video back to mission control. This wasn't just great for SpaceX, but it also allowed us to see the condition of the heat shield much more clearly after re-entry. That zoom in on the tiles from the drone, we want more of that, SpaceX. The ship continued transmitting telemetry for hours after landing, so it likely remained afloat for quite some time. We're not sure what plans SpaceX has for it, but we're keeping a close eye on their recovery ship, Go Australis, out there in the Indian Ocean. Flight 13 gave us quite a show, and it's a reminder that sometimes certain parts of the program can still lag behind others by quite a bit. According to Elon, pending a data review, they may very well bring the next ship back to the pad for a catch attempt. This would mean Flight 14 is an orbital flight, and that's entirely possible thanks to Flight 13's demonstration of the in-space burn with Raptor 3. This could also allow the deployment of Starlink V3 satellites into orbit for the first time, potentially making it a real operational flight for Starship. The booster, on the other hand, presumably Booster 21, might have to perform another splashdown test to refine the boostback and landing burns. This means there could be a ship catch, but no booster catch on the next flight. It is definitely an interesting time to be following the Starship program. We'll bring that to you in future episodes of This Week in Spaceflight and of course our dedicated Starship update shows. Now, back to Alicia.
Rocket Lab is headed to Alaska. The U.S. Space Force has just awarded the company a $266 million contract for 12 suborbital missions from the Pacific Spaceport complex on Kodiak Island. The deal has options for 6 more missions running through the end of 2028. These missions will use the company's HASTE vehicle, a suborbital variant of its Electron rocket, which its defense customers have used since 2023 to test hypersonic technology. These missions won't reach orbit, but instead will arc up and back down, which is exactly what you want if you're testing how hardware survives extreme speeds and re-entry conditions. This is new ground for Rocket Lab, whose 9 HASTE missions to date have all launched from the Wallops Flight Facility in Virginia. The relationship with Alaska goes further back than you might think, though. Over 10 years ago, the company picked the Alaska Aerospace Corporation, who runs Kodiak Spaceport, to handle range safety for their Electron launches out of New Zealand. Now, Alaska will be where these new missions will be launching from, but there's another country worth mentioning here too, which is Australia. Re-entry capsules built on Rocket Lab's Pioneer spacecraft platform for Varda Space have been touching back down on Earth at the Coonibba test range in South Australia. 4 have landed there since February 2025, with the most recent returning to Earth in May. However, new job postings for test and launch operations in Sydney and Melbourne appeared this week, causing some to wonder if the company might be expanding deeper into Australia. These also happen to coincide with a declaration by the Australian Space Agency to expand its domestic launch capabilities, but the idea of Rocket Lab also launching from Australia has since been brought back down to Earth. We reached out to Rocket Lab, and they denied having plans to establish a launch site in Australia. So why the job posting? Well, apparently, they often advertise New Zealand-based roles in Australia too, as Australians can work in the neighboring country visa-free. Rocket Lab just celebrated its 20-year anniversary earlier in July and is closing in on its 100th launch, which is expected later this year. The company announced in late June that it's acquiring satellite operator Iridium in an $8 billion deal. This will see Rocket Lab go from just building and launching hardware into a fully integrated company that runs its own satellite network too. As Neutron moves towards its maiden launch from the new Launch Complex 3 at Wallops, we're looking forward to seeing Rocket Lab add yet another spaceport to its list of launch sites. Now we'll take a look at some other stories across space, starting with a progress update from the Artemis program. As NASA continues to prepare for the Artemis III mission, the 4th and final RS-25 engine has arrived in Florida. The engine left NASA's Stennis Space Center in Mississippi, where it performed acceptance testing. It joined 3 others at the Kennedy Space Center, where the 4 will now be prepared for installation with the SLS core stage. This will be the first time that engines are integrated with an SLS core in the vertical position, which simplifies the installation process and gives better access to each engine. These 4 engines have flown on 36 space shuttle missions combined, including ISS assembly flights and John Glenn's return to space mission, STS-95, in 1998. L3 Harris has upgraded these shuttle Heritage engines with modern electronics and new insulation, and they'll run at a higher thrust too. Later missions from Artemis V will be using a series of newly manufactured engines, the first of which was already hot-fired over a year ago. Elsewhere, other pieces of the mission continue to come together. The twin solid rocket boosters for the SLS rocket have begun stacking in the vehicle assembly building. Additional segments are being prepared in the rotation, processing, and surge facility, and 10 motor segments will eventually make up the pair of 54-meter tall solid rocket boosters. Technicians finished attaching the Orion spacecraft's heat shield in early July. It's built from 186 individual blocks of Avcoat, an ablative material designed to char away and take the heat with it during re-entry. Each block was inspected one by one before installation. This level of scrutiny was prompted by the analysis of the Artemis I heat shield. NASA found that the coating had lost more char than expected in a few places, caused by gas building up inside of the material during the mission's skip entry profile. The blocks have now been refined for even more permeability on the Artemis III mission, so the shield chars away exactly as designed. A booth at July's Open Sauce Convention in California illustrated sections of the heat shield from the first two Artemis missions side by side. The Artemis II mission used a steeper re-entry trajectory to reduce the time the shield was exposed to extreme heat. With every major piece now on site at Kennedy, Artemis III is really coming together. The mission is currently slated for next year, when it will send astronauts aboard Orion to test rendezvous and docking with demonstrators for the human landing system ahead of the Artemis IV moon landing, currently planned for 2028. The RFA ONE rocket is stacked and sitting on the pad for the very first time. It's seen here on Launchpad Fredo at the SaxaVord Spaceport in the UK's Shetland Islands, and when it takes its maiden flight, it's going to set a few milestones. This will be the first launch for both the German launch provider Rocket Factory Augsburg and for the Spaceport, and this will also become the very first vertical orbital launch from UK soil. RFA says the launcher is now fully integrated with its fairing capped on top and is awaiting a first-stage hot-fire test. The company has yet to perform a test with a fully assembled rocket and hasn't officially said if a payload is also integrated. This would be a bold move given what happened during the rocket's previous static fire. After completing a successful static fire of the Helix engines on the first stage more than 2 years ago in May 2024, the company attempted a second static fire that August, but it didn't go to plan. The fire tore through a turbo pump, taking the stage and a chunk of the launch pad with it. This led to 18 months of rebuilding, and during that time, the company has also been testing elements of its Helix 2.0 engines, which will deliver double the thrust of their current engines in the future. Back in late 2022, the debut was set to launch 7 small satellites as part of the German Space Agency's micro-launcher competition, though RFA has yet to confirm that they're still on the manifest for this flight. RFA ONE is set to launch no earlier than August 10th, so we'll be keeping a close eye on SaxaVord over the coming weeks. Japan Space Agency JAXA finally successfully tested its Epsilon S solid rocket booster after 2 failures. Epsilon S is supposed to be an improved version of the Epsilon rocket, which saw its last flight in 2022 and in itself is an evolution of the MV rocket. The Epsilon S shares its first stage with Japan's new H3 rocket, which uses the same rocket motor as its solid rocket boosters. Epsilon S was also set to get an upgraded solid second stage named E21. JAXA test-fired it in July 2023, and it failed, damaging its test stand. Then in November 2024, they tried again with similarly destructive results. It appears that both times, the motors performed better than expected and burned through their cases, leading to the explosions. Well, this week, JAXA tried again. Well, sort of. They did successfully fire a second stage for Epsilon S, but it wasn't the E21. Instead, they went back to the proven design of the M35 motor that flew on previous Epsilon rockets and reworked its design into the M35A. With it tested successfully, they now have a path towards getting Epsilon S off the ground, and the first launch is still set for no earlier than 2026. In other news from JAXA, remember that hopper from last week? They hopped their RVX, a small prototype for a reusable rocket during a 40-second flight that looked a lot like the Starhopper tests from the early days of Starship. Well, this week JAXA announced that it was the program's only flight. Apparently, JAXA got the data that they needed out of the test and decided to call it quits. Now, unlike Starhopper, this program was never supposed to directly lead to an operational rocket. Instead, its results will feed into another experimental reusable rocket called Callisto that JAXA is working on with its French and German counterparts, CONOPS and DLR. We covered it in detail in last week's episode in case you want to learn more. All in all, I guess it's not too surprising to see JAXA pull the plug on RVX after just 165 engine tests and one flight, but as fans of rocket tests, we certainly wouldn't mind if they gave it a few more goes. Fortunately, we did get more launches to look at this week, so let's take a look at your weekly space traffic report provided by Next Spaceflight. Starting off the week, India's Skyroot Aerospace launched its first orbital mission, and it was a success. The company had been working on its rocket, called Vikram 1, a small-sat launcher capable of lifting 350 kilograms into low Earth orbit using 3 solid rocket stages and a liquid-fueled fourth. On July 18th, the very first Vikram 1 lifted off from the first launch pad at India's Satish Dhawan Space Center, marking the country's first private orbital launch attempt. The rocket performed as expected on the way up, and several tense minutes later, Skyroot announced mission success. Vikram 1 carried 4 payloads, including a small robotic arm, which were all injected into a 450-kilometer orbit. Congrats, Skyroot! Next, Russia launched a Soyuz from Plesetsk, carrying 16 Rassvet 3 satellites for Russian satellite internet company Bureau 1440. Over in China, we had the launch of Orion Space's Gravity 1 rocket, lifting off from the Dongfeng Hongtiangong barge stationed in the Yellow Sea. The mission delivered 9 satellites into sun-synchronous orbit. Later in the week, CAS Space, another Chinese commercial launch provider, launched its Kinetica 1 rocket from Zhochuan. Meanwhile, a Changzheng 3B lifted off from China's inland Xichang spaceport, and it was definitely a launch for the books. Encapsulated in its fairing, it carried a satellite for China's Tianlian Communications Relay Constellation, which plays a similar role as NASA's TDRS network, supporting communications for the country's human spaceflight program. But the payload wasn't what made this launch so interesting. It was what happened on the way up. Approximately half a minute into flight, the rocket was struck by lightning. Now, we typically don't want this to happen in spaceflight. It was what caused the failure of the Atlas Centaur 67 mission in 1987, and we usually avoid launching in lightning-prone conditions for that reason. But the Changzheng 3B continued its ride up unscathed, putting it into the company of Soyuz 2, which successfully delivered a GLONASS navigation satellite in orbit in 2019, after also being struck by lightning on the way up, and of course, the famous Apollo 12 mission, which was struck by lightning twice and still delivered its crew to the moon. After they switched SCE to aux, of course. While the lightning made this otherwise fairly standard Changzheng 3B launch a lot more spectacular, we hope to not see it again because this could have gone much, much worse. SpaceX also launched a few times this week, with 2 Starlink missions lifting off from Vandenberg in California. On the other side of the country, Falcon 9 lifted off from Cape Canaveral, carrying the MRV-1 mission for Northrop Grumman subsidiary Space Logistics. MRV stands for Mission Robotic Vehicle, which is a satellite designed to attach mission extension pods to geostationary satellites and give them a new lease on life. This week's launch carried 3 of these 400-kilogram pods, 2 of which will extend the life for satellites from Intelsat, and the other will service a satellite for Optus. If resupplied with more pods, the MRV on this launch can attach 30 of these MEPs during its designed life. In a rare occurrence, Falcon 9 flew expendable on this mission, with booster B-1069 flying its 32nd and final mission. Of course, SpaceX also had another attempt at launching Starship's Flight 13 this week, but Ryan already told you about it earlier in the episode. Next week, SpaceX plans to launch 2 more Falcon 9s, one from Vandenberg lofting more Starlinks. The other is set to carry a classified mission for the U.S. National Reconnaissance Office. This mission will lift off from the Cape, and its booster will also land at the Cape for a return-to-launch site landing. So expect sonic booms if you're in the area on July 30th. Over on the ISS, the Soyuz MS-28 capsule and its crew are set to depart the station on Sunday morning UTC after an 8-month stay. The capsule will touch down on the steppes of Kazakhstan a few hours after undocking. And China plans to launch a Changzheng 7A from Wenchang and a Changzheng 6A from Taiwan. Now, there are still more missions set to lift off before the end of the month, mostly Electrons from New Zealand, but we haven't seen Aerospace or Marine notices for any of them. If Rocket Lab manages to sneak another launch in before the end of July, you'll certainly see it on Next Spaceflight. It's the best way to stay up to date with launches, and it's completely free. And that's your weekly update of spaceflight news. I'm Alicia Siegel for NSF, and we'll see you all again next week to recap this week in spaceflight.